Our challenge is to subtract these two rational expressions. We begin by step 1, finding the least common denominator. Well, to do that, the actual first step is to factor. This factoring allows us to see what in fact they already have in common and what needs to be written to create the commonness. Naturally, we know that all of the factors from the first denominator will ultimately be included in our final denominator. Then we look to the second denominator, observing which factors are not yet present. Since the x plus 2 is present, it's only the 5 that is missing. So that tells me I need to multiply by 5 in each the numerator and the denominator. If we haven't already grouped with parentheses, this would be the moment to do that, to remind ourselves that eventually that 5 will need to be distributed. Notice how what we've multiplied by is a version of the number 1. We continue by looking at the second element in our subtraction and observing its current denominator. It has factors 5. It already has an x plus 2. So what's missing? It's going to need the term x minus 3. And again, we are reminded that to be legal, we must multiply both the numerator and the denominator by a version of the number 1, in this case the ratio of x minus 3 times x minus 3. Now, looking ahead, we know that of these three identical terms, we knew that the 2 from the first expression needed to be present, and what has been added is a factor of 5. We now have our lowest common denominator. What remains to be done next is to distribute in our numerator. So we would have 5x minus 5, and then noticing that this subtraction requires thinking about this as adding a negative 4 that is to be distributed will help avoid some common errors with signs as we simplify. Negative 4 times x, negative 4x, and distributing negative 4 times negative 3 is adding 12. It is time to combine terms in our numerator, and notice that the denominator is kept as factored form. Combining like terms, 5x minus 4x leaves us with x. Negative 5 plus 12 would lead us with an additional 7. Leaving this factored form in the denominator is a fairly common occurrence, so that we may once again look and make sure that there aren't any common terms after we've combined that should be still divided out. In this case, x plus 7 as a binomial cannot match either of the factors here, so it is okay to leave this form. It will also help remind us that we need to note what values would make this expression undefined. So we notice then that x cannot equal a negative 2 or a positive 3, which would create a denominator of 0.